Hello everyone. So in this video we are going to analyze one dataset downloaded from UCI Machine Learning Repository, which is of customer churn. Let me first show you the dataset. First let's import the pandas. This is a CSV file. So this is how the dataset looks. If you look at the last column, this churn, so this is the target feature. First of all, let's understand what's customer churn or churn. So whenever a customer does not want your service, or they want to leave your service and move to some other company or other service provider for the same service which you are providing, that is customer churning. And let me show you something here. Let's assign a variable df and churn dot value counts. If you see, this 0 represents the customers who are not churned and the 1 represents the customers who are churned. So this is the figure, or this is the value, or this is the parameter that we are going to focus on. Now if you see, if we do train test split and train our model, so the results that our model will be providing is probably skewed because the class is imbalanced here. We have 2655 customers who are not churned and 495 who are churned. So we need a kind of a balance here. So let's create the instance of our logistic regression model and let's train the model, and let's generate a classification report where we can see the parameters like precision or recall, and there we'll have a more clarity on this. So first let's import sklearn dot model selection, and from here we'll import the train test split. First let's classify the data with target and non-target features. The target feature is churn, so we'll drop it from the data frame. So this churn, and axis is one, which is nothing but a column. So if you look at the x here, see the churn is not here, and y, it's only one feature which is churn. Yes. Now let's do train test split, which will take x, y, then test size, let's say 25%, and random state is 42. Now this could be anything, just to make sure of the reproducibility, which in turn returns us x train, y train, y test. sklearn dot linear model import logistic regression. Now let's train our model. Model dot fit x train, y train. Okay, we can ignore this. Now our model is trained. Let's predict the values also. Model dot predict what? X test. Now let's generate a classification report, which is nothing but a metric, and by using that we can evaluate our model performance, and we can import it from sklearn.metrics import classification, oh no, classification report, yes, this is the one. Classification report. Now any as in any other metric, this will also take the true value of y and the predicted one. So true value is y test and predicted is y pred. Let's assign one variable and print the classification report. Now as you can see, we have received our classification report here. Now let's focus on this column only, because one represents the customer churn and we do not want our customers to be churned here. And also focus on this column, recall. So what this 0.15 represents? It represents that out of all the customers who are churned, or out of all the customers who have left our service or our product, out of those only 15% we have found out. Now I am not expecting that we can find out 100% of those, but this value, this figure should be as higher as possible. Now 0.15 is too low. Let's see one more thing here, which is y train dot value counts. Now as you can see here, the customers who are not churned is 2010 and the customers who are churned is 352. Now here the class is imbalanced. Now there should be some balance in between two. There is so much difference in both the classes, the churn and not churned. Now there are few methods or few ways by using which we can mitigate this class imbalance problem. Now one of those is undersampling. Let's apply that and see the difference with this recall parameter here for churn customers. So we can import that from one module or library which is imblearned. Imblearn dot undersampling import random undersampler. Now random undersampler, which will also take one parameter, random state. Random state, let's give 42. Did I import oversampler? No, undersampler. Why is it giving oversampler? Yeah. And okay, now this random undersampler we take two arguments, which is x train and y train. We are not going to touch our test data here. Random undersampler is not callable. Let's run all the cells. there is a function fit, yeah, fit resample, and it takes arguments x train, y train. Yes. Now here, as I mentioned, we are not going to touch our test data. We are only going to apply this random undersampler on our training data. In return, it will provide us x train RUS and y train RUS. Now let's do the same thing which we have done here. Let's train our model and generate a classification report, but with these two newly created sets, which is x train RUS and y train RUS. So x train RUS and y train RUS. Predict x test, that is fine. Let's rename this ypred also, ypred RUS. Now we have generated our classification report here as well. Now as you can see, this 0.8, what does this mean? So out of 100 customers who are going to be churned, we have found out 80% or 80 customers. Now what we are going to do with those customers, that is another story, but we have found out these many customers are going to leave. So this is the magic of the random undersampler. Now there are other functions or other ways as well for mitigating this class imbalance issue. Now let me show you one more thing here. What does y train RUS contains? Value counts. See, earlier when we printed this value, the customers who are not going to be churned is 2010 and who is going to be churned is 352. So here both are 352. So what really happened is the majority class, the class which contains the customers who are not going to be churned, shrinked or is made equal to what the minority class is, which is 352, and that is why we have improved our recall value here. So that is about everything about the class imbalance and random undersampler.